You can use simcision to analyze complex questions. Let's build a simple model together to get to know the concepts behind the software. First up, define your system context. What question are you trying to answer? Try to be detailed and think of a concrete issue that can be changed in a set amount of time. What time frame is relevant? Are you looking at changes over days, weeks, or months? The fastest significant change in your model determines your level of granularity. Once you've set your context, it's time to start building your model. To begin, define elements relevant to your question. Can you think of anything affecting the issue you're analyzing? Select the Target Element tool and click anywhere to create your element. Give it a name. Create as many as you like. I'll start with only a few for the moment. You can always add more later. You can move, rename, or delete elements easily. Each element represents a value important to your system. When building a causal model, I mainly use target elements. These work great for abstract values that are not easily quantifiable. They have a value range from 0 to 100%, which is nice for concepts like collaboration or innovation. I usually try to formulate a positive title for all elements. That way, you can deduct that high values are always a good thing. If you have clearly measurable values, use resource elements instead. You can define their range and unit yourself. I'd recommend staying on the same level of abstraction across your model. Don't name your element higher job satisfaction. Simplify to job satisfaction. The relationships in your model will naturally increase or decrease these values. Speaking of relationships, let's get onto that. Start connecting your elements now. Connecting the different values of your model through relationships is what makes a system out of your elements. A relation is always created from one element to another element. Select the base element, the one causing the change. Activate the connection mode. Select the end element, the one affected by the change. Now we are about to create an impact relationship between the two elements. Before you do that, ask yourself, does changing A lead to a change in B? If yes, there might be a connection here. Then consider how changing A affects B. If A increases, does B increase too? Then it's a reinforcing relationship. If A increases and B decreases as a result, it's a reversing relationship. Create the impact relation. Nice. You just linked the two elements. Now whenever the value of A changes, the value of B will change subsequently too. Rinse and repeat. What relationships are there in your system? Look for stories in your model. What might cause values to change? What consequences might follow these changes? And be critical. Are you sure there is a direct connection between one element and another? Or could there be an element in between acting as a bridge? Indirect connections are a thing that you have to keep in mind. Next, set starting values for your elements. For abstract elements, you can create a list of measurable indicators to guide your value estimation. You can update the value in the sidebar or directly on the canvas. If you use resource elements in your model, don't forget to set their lower and upper limits along with their units. Once you've assigned values to your elements, the next step is defining the strength of their relationships. We defined when A increases, B increases too, but by how much? Start by making a first estimate. Is the influence weak, medium, or strong? That is your base strength. So, how does the strength of a relation translate to changes in the model? Let's take a relation with a base strength of 50 and look at it in the simulation. Let's switch tabs. You haven't worked in the Network tab until now, where you build the model. Each other tab gives us a set of useful tools to interact with the model you just set up. Let's go to the Simulation tab for now. I will cover the other tabs in separate videos. In simulation mode, you can change the values of the elements in the model and see how these changes affect the rest of the system over time. Start a new simulation in free mode for now. You can see two time bars here. One on the side and one on the bottom. As you can see, the simulation is as long as we set it up in our system context at the beginning of a tutorial. Let's change the value of a base element from our relationship. Currently it's set to 0%. We can change its value using an impulse. An impulse is a change to the value of an element at a specific time. Let's apply the impulse at the first possible moment, week 1. Here we can create the impulse for the element pay equity and set it to plus 50%. We don't see any change yet. That's because we need to advance time to see the effect of the impulse. Start the simulation. Okay, it started. We're at the beginning of week 1 now. The simulation always pauses at the start of a time set and lets us see the upcoming changes that will happen in this time period to be able to react to those. We can see that the value of the element pay equity will increase by 50%. Continuing the simulation will apply the changes. The element pay equity receives a change and rises to 50%. Afterwards, the relations activate. The relation we set up added an impulse to the end element with an increase by 25%. Okay, what happened and why? We can open up the info panel for the relation by double-clicking on the connection arrow. This is the relation strength we just set up. The influence curve defines how strong the impulse on the end element will be. We started at 0% on the base element, pay equity. The value of a base element is indicated by the x-axis of a chart. We're at 50% now. The value of the impulse on the end element is determined by the change of value in the y-axis. We started at 0 but ended at 25. This difference is the value that the end element gets as an impulse. If we simulate the next time step, this impulse is then added to the end element. It's now sitting at 35%, since it already had 10% beforehand. Let's do it again with an impulse of 20%. The value of the element rises by 20% to 70. The end element gets an impulse of plus 10. Let's look at the chart again. The pay equity element started at 50%, which resolves to a value of 25. We increase the value by 20% to 70, where we are now. That gets us an y value of 35. The difference between 25 and 35 is 10, and this is what was added to the end element. This behavior is quite simple as long as we use linear influence connections, but we can use different connection types to model unique behaviors. For example, we could use a saturation curve to model a relation with a lot of influence, and there's change in the lower numbers, but less as we near the maximum. This is how to model a relation with diminishing returns. You can also adjust this curve freely to really model individual connections. Another thing you might have noticed is that the value of the affected element changed one step after the source element. All relations have this time delay built in. They always take at least one time step to propagate the impulse. How long is this time step? That's the time we chose in the system context at the beginning of a tutorial, a week. In simple terms, we can now describe the relation as follows. Increasing the pay equity will strongly increase the employee morale in a week. Some relationships might take longer to leave an effect. In that case, you can always increase their delay. Now you've seen the basics of simcision, defining elements, creating relationships, and running simulations. Do this on repeat, test out the results, and you'll have a solid model in no time. Creating the model is only the beginning though. Watch the next videos of the series to learn about interventions and scenarios as a way to interact with your system, analyzing your model to gain insights about loops and influences through relations, and evaluating your simulations to compare different simulation results and understand where changes came from. See you next time. And keep in mind, every model is wrong, but yours may be useful.